How do operational amplifiers, op-amps, work? Imagine you have a tiny device that can take very small signals and make them much bigger without losing their original shape. That's what an operational amplifier does. It's a small chip used in many electronic circuits. But how does it actually work? Let's break it down. An operational amplifier is designed to compare the voltage onto input terminals. One is called the non-inverting input, marked with a plus sign, and the other is the inverting input, marked with a minus sign. The op-amp looks at the difference between these two voltages. If the voltages are different, the op-amp produces an output voltage that is proportional to that difference. The key thing about an operational amplifier is its open-loop gain. This is a very high number, often around 100,000 or more. It means even a tiny difference in voltage between the two inputs causes a large change in the output voltage. For example, if the difference is just a few millivolts, the output could swing to hundreds of volts, hitting the power supply limits. That's why without any feedback, an op-amp acts like a switch or a comparator, going fully high or low. To use an operational amplifier for linear amplification, engineers add a feedback loop. This is a connection from the output back to the inverting input. Negative feedback keeps the voltage difference between the inputs very close to zero. This stabilizes the gain and makes the output proportional to the input signal. It also prevents the output from saturating at the supply voltage limits. In practical terms, the op-amp has very high input impedance, meaning it doesn't load the signal source. It also has low output impedance, so it can drive other parts of the circuit easily. These features make it perfect for tasks like buffering signals, filtering noise, or amplifying tiny sensor outputs. The main characteristics of an operational amplifier include its high gain, differential input, high input impedance, and low output impedance. It can handle a wide range of frequencies and change its output quickly, which is important in many applications. In the world of electrical engineering, knowing how an op-amp works is essential. It helps in designing circuits that process signals from sensors, create filters, or build control systems. Understanding its operation is also a strong point in technical interviews, showing your grasp of core analog circuit concepts. So, to sum up, an operational amplifier works by amplifying the tiny voltage difference between its two inputs. With the help of external feedback, it becomes a precise tool for controlling and shaping signals in countless electronic devices. This understanding is a foundation for many career paths in electronics and circuit design, making it a vital skill for professional growth.